Hey guys, Mr. Stevens here with our first lesson in our probability unit. What we're going to be looking at today is some important definitions and how we talk about probability, and particularly how we convert probability in words to probability in maths. And then we're going to calculate some simple probabilities. So, important things you're going to be able to do at the end of this lesson are define these three words, and we're also going to calculate the probability of an event occurring. Let's look at some of these definitions. The first one is the sample space. The sample space is every possible outcome of an experiment. While we're talking about these definitions, I'm going to use the example of rolling a standard six-sided dice. So the sample space of rolling a standard six-sided dice are the numbers 1, 2, 3, 4, 5, and 6 on the 6 different faces of the dice. The sample space is every possible option we can get when we roll a dice. An event, however, is a collection of possible outcomes from an experiment. So, for example, rolling a number higher than 4 is an event that can happen when you roll a dice. And the important thing to note here is that the favourable outcomes are the positive outcomes, if you like, to the event. The outcomes where the event is fulfilled. So rolling a number higher than 4, the favourable outcomes are the numbers that you roll that are higher than 4. And the reason that's important is we use that number of favourable outcomes to calculate the overall probability by dividing the number of favourable outcomes by the total number of outcomes in the sample space. So in this case, for rolling a number higher than 4, the probability would be 2 over 6, or 1/3, because there are two favourable outcomes to that event. There are two numbers higher than 4 that we can possibly roll, they are 5 and 6, and there are 6 total possible outcomes, 6 sides of the dice. Now, another important thing we need to know is we need to know how to communicate probability when we're writing things down. And this is the general form for writing the probability of an event. P to designate probability, and then in brackets you write the event. So in our example up here, you would write in this space and rolling a number higher than 4. Now, something that you might notice about the way our formula works up here is that the number of favourable outcomes on top of the fraction will never be more than the total number of outcomes. That wouldn't make sense. At most, that number on top of the fraction will be the same as the total number of outcomes. So when we're calculating a probability, it can never be bigger than 1. It will always be between 0 and 1, the probability of any event occurring. And the last important definition we need to look at is the complement. The complement of an event is the probability that the event will not occur. The two events together, the event and its complement, form a pair where the whole probability is equal 1. So, for example, back up here, the probability of rolling a number higher than 4 is 1/3, like we calculated. And then the complement of that, the probability of rolling a number less than or equal to 4, is 1 minus this probability, or 2/3. And you can check that by calculating that probability from scratch. There would be 4 favourable outcomes in this case, the numbers 1, 2, 3, and 4, over 6, which equals 2/3. So that's good. These are the same. That's what we want. So when you're dealing with the complement, you can either calculate the probability which in this case was fairly simple to do. Or if you know the probability of an event and you want to work out the probability of the complement of that event, you can simply do 1 minus the probability that you know. Alright, let's look at an example. This is a fairly simple example, so I'm going to go through it pretty quickly. The sample space are all the possible... We have a spinner here. Sorry, I should have explained that first. We have a spinner here with 5 equally shaped sections. If we spin the spinner, what number are we going to land on? That's what we're going to calculate here when we're calculating probabilities. The sample space are all the possible numbers that we can land on. So the sample space is 1, 2, there are 3 3s and a 7. The probability of getting a 3 is the number of favourable outcomes. There are 2 3s on the spinner, so there are 2 chances for us to land on 3. And there are 5 total outcomes. That number on the bottom is always the total number of outcomes. The probability of not 3, we can either find it out by recognizing that that is the complement, or because it's such a simple probability, we could have just done there are 3 outcomes that are not 3. So we could have just gone straight to 3 over 5. But I want you guys to recognize that these 2 events are complementary. And then the probability of a 3 or a 7, that means one of the 3s or the 7. We have 3 possible favourable outcomes. And again, there's still 5 total outcomes. Probability of getting at least a 3, in that case, all of these numbers are options. 1, 2, 3, and 3. They're all at least 3. The only unfavourable outcome here is the 7. So this one is 4 over 5. Second example here, randomly choosing a letter from the word probability. I'm going to calculate the left column for you, and then I'll get you guys to have a go at the right-hand column for yourself. Now, this is our sample space up here, the letters in the word probability. There are 11 letters in this word, so our total number of possible outcomes is going to be 11. In this first case, probability of selecting the L, there is only one L, so the probability is 1 over 11. Now, the complement of that, not L, I could calculate it by going 1 minus 1 over 11, but in this case, I'm going to do it the other way. I'm going to recognize that L is one of my options. So that means the rest of my favorable outcomes, there is 10. There are 10 other letters I can choose that are not L. So my favorable outcomes are 10 over the total number of outcomes, 11. And you can see that's what I would have got if I had done it this way as well. In the probability of choosing a vowel, the favourable outcomes here are the O, the A, or the 2 I's. That means I have 4 favourable outcomes divided by the total number of outcomes, 11. So the probability of selecting a vowel is 4 over 11. Now I'll get you guys to have a go at 1, 2, and 3 in the right-hand column. And if you pause the video, have a go at them. When you come back, I'll write down the solutions for you. So hopefully you will have recognized that these 2 form a complementary pair. So if the probability of selecting a vowel is 4 over 11, that means the probability of selecting a consonant has to be 7 over 11. Now the probability of a vowel or a B, we know there were 4 vowels from this question, and there are 2 B's, so the favourable outcomes are going to be 6 over 11. This one here, the probability of selecting a vowel or a consonant, all the letters in the word are either a vowel or a consonant, so all letters are a favourable outcome here, so the probability of selecting a vowel or a consonant is 1. So what I'll get you guys to do now is make sure that you can define these 3 important words, sample space, event, and complement. And we'll do some questions now from the textbook to make sure that you are able to calculate the probability of an event. Thanks, guys.